Welcome back to Toss a Coin to Your Tech Guy. I'm John, your tech guy. You guys ever get into a project that feels like it's just going to go on and on and on and on and things keep breaking? Yeah. All right, guys, it's been a couple 2-3 days bopping this thing around and we have a problem. So beforehand, when we changed out the switcher, the fuel gauge was reading way over full. Well, we're back to that scenario. So I'm thinking wiring causing high resistance somewhere because the fuel senders will work intermittently, or there's a loose connection or something, which is also a good possibility. But here we go. Let's dive into it. All right, as you guys can see, yeah, she's doing the same thing all over again. And if we turn on the keys here for a minute and switch between tanks, you're going to notice that it doesn't actually affect it right now. It's big mad. So what I think I'm going to end up doing, all right, keys on, switchy, nothing. So I think I'm going to end up doing, I'm going to take this here valence off, and then we're going to start debugging the switch and also the yellow and white wire that feeds the gauge from the switcher in the back. So we know the switcher is new and we know it sort of kind of actuates, so we're gonna assume maybe it's doing the thing. One of the things they don't tell you about whenever you go to start doing this kind of stuff is how difficult it is to find filming angles. And I tried putting you in the cup holder, I tried putting you on the seat, I tried propping it up on a bag. None of this works, so we're gonna try this one-handed. So anyways, if you go to get this valence off, you got one of these Fords, there's 2 screws and they're hidden behind that little trim piece I just removed on that side, and then there's another one over here on this side. And I'm gonna try to remove without completely, and totally destroying things. Sometimes you need a little screwdriver to get in here, or a pocket knife. I'm just using my fingertips because these are quite old and they've been off several dozen times. You're also going to notice that right down in there, that little guy is a Torx driver bit that you will need to take that guy off. Proper bit that fits, if the single focus, there we go, is a T20. You guys may notice I'm filming inside the truck today. It has decided to be extremely windy outside, and getting anything done where you guys can hear me is completely impossible. And this monster doesn't fit through the shop doors or in the garage very well without some serious retooling. So we're just going to work inside today a little bit, try to relax. It's kind of been an interesting week recovering after the tour. Won't come off. So these little guys are actually just sheet metal screws, Torx head sheet metal screws. And yeah, see, as you can see, they slot through right here into a little metal retaining clip. It's nothing special, it really isn't. Now the other thing we're gonna have to do before I can get this valence off is you see that headlight button above where I'm working right now. We're gonna need to weasel that out, and that's actually kind of tricky. You guys are gonna have to see me fail on that pretty quick. Come on off there. Yeah, I suddenly understand the other YouTube guys, man. They complain about doing stuff one-handed all the time. It's a serious problem. Okay, so this is an aftermarket knob, so I can just pop that guy off pretty easily. You see, and there's the retaining clip here. We'll push that back in so my headlights don't run. But on the factory knobs, that's gonna be pretty dadgum tight. So you gotta be careful, 1, not to just break the knob off, and 2, not to break this or pull this retaining clip completely off of this guy and bugger it, because you only get one and that's it. That's mine. All right, so here we go. We got our valence loose. Now what you want to do when you go to take this off is you're going to want to work your way around very easily, very gentle. Nothing you do here needs to be violent. Let me set my e-brake because I'm going to have to move the shifter. But be ginger careful, guys, because if you go in here and you start going at this ham-handed, that's how you break these things, and you're going to see in a minute all the little plastic clippies and tabs and stuff that are on the back of this. You don't want to, I need a key for that. You don't want to go ahead and break that off, because if you do, you'll have to buy a new one. And these have gotten a lot cheaper than they used to be, but it's still not great. I mean, I don't want to buy a new one. So I'm going to throw this down as far as I can. I'm down to 1. turn this back off a little bit so we save some power, and then we're going to see if we can't weasel this guy back out of here. I might have to set you guys down for just a quick hot second to get this out, but I don't know, it's coming, so we're going to give it the benefit of the doubt. Oh, the other thing I got to do is move my obnoxiously large screen. I'll talk about this later, out of the way. And yeah, there we go. All right. So like I said, just easy, ginger, careful. Don't force anything. If it's too hard, you're doing it wrong. And this whole assembly will eventually fall back. Now, careful pulling too hard. I'm gonna try to get you guys in here where you can see, but I don't know if you guys can see that or not. Here we go. Yeah. See, there's a wire connector here, and there's one on the other side for the indicator lights. You definitely want to take those loose. If you do not, you risk pulling them out of the harness. So I'm going to do that off camera here and pick you back up in a second. I'm loose. So one thing I have learned on these old trucks is that all these plastic components that have been on here for 30 years are brittle, and extremely so. So this guy, these little ears down here, they get brittle. This is an aftermarket bezel, so it's still pretty flexible, but this isn't, and this guy over here isn't. This guy's actually pretty expensive, which is hilarious to me because it's just a PCB. Let me get it in frame. A PCB trace with a few lights. So, I mean, I don't know why that's that expensive, but it is. And then this guy here, this is just a 2-position switch that controls your switcher at the back, which future John should have gone over the schematic with you by now, so you know how this guy works. I was completely wrong. First time since last time. If you look at the circuit diagram, it actually makes a lot more sense and is a lot more caveman than I was initially thinking. Hey, it's a more modern car than a lot of the things I have, so I was thinking modern. You guys get it. All right, so here we go. So we got our instrument cluster bezel, got some more of these little Torx headed screws. Some of this is a little plasticky and broken. 30 years will do that to you. But what I'm actually going to try to do is I'm going to try to pull this back and inspect the connection at the back of the instrument cluster and see if maybe it just needs a little cleaning. But let me get these screws out and we'll see what we can do from there. Now, I think these are the same T20 size as the other ones, if I remember correctly. Nope, I'm wrong. First time since last time. Looks like those are not T20s. Those are, let's see, survey says maybe T15. Take a look. Yes, T15. So if you got to go get at this, you need a T20 Torx driver and a T15. And every other tool under the sun, because you go to the parts store, it's like going to Candyland. In my case, what ends up happening is my kid drags me around the toy store, and I swear she wants more things out of there than I do. The Hazard Fraud and Home Depot and all these other places are very dangerous for dads to go into with their kids. All right, let me get the rest of these out, and I'll pull this back. What I think is we're going to find a couple of crusty connections, and we'll be able to actuate this with everything pulled apart and see if we can get that gauge to play more or less correctly. Anyway, here we go. The astute among you may have noticed that I was taking out the wrong screws. This actually just holds on the clear plastic lens here. The actual screws are T20, and they exist over here, right there. I should have followed my first instinct instead of looking at the shiny thing. You guys know how it is. You see a shiny thing and, oh, squirrel moment, it's over there. What is it? Anyways. Bolt this thing back together and give her another try on the other side. All right, so we use our proper T20 bit to pull this apart and get this here bezel out. Doing this one-handed is a lot more difficult than I would have otherwise anticipated. I think I've mentioned that a couple times. Good grief. Ah! Oh, there goes one. Okay, Narnia. We'll get it in a minute. This gives me a chance to tell a story. I mean, my dad used to have one of these trucks. And he had the naturally aspirated version, which was the 7380i. And He loved that truck, but it was rattly and terrible. His old farm truck. I mean, at the time it wasn't that old, but it was old by the time we got done with it. And he used to pull a camper with that thing, just flat out. And this truck reminds me a lot of that because it smells very similar. And I'm half expecting to pull one of these panels apart and find a toy that one of me or my brother hid in one of these things. I haven't yet, but who knows? Stranger things have happened. But nah, these are great, reliable trucks. The plastics in them leave a little to be desired, but drivetrain you can't shake a stick at. So anyway, I mean, until your fuel gauge goes pear-shaped, and then, well, here we are. Okay, so come here, reveal your secrets to me. Oh, I must, yep, I gotta lower the steering wheel and get you guys back in frame so you can see what the heck is going on. So to wiggle these guys out is a little bit of a ballerina dance, and doing this one-handed is also probably not great, so I might have to set the camera down here for just a second, but we're gonna see if we can get her. So we're gonna weasel this guy out. I said we're gonna weasel this guy out. I said, come on now, please. Earth to freaking instrument cluster. Ah! There's probably some of you guys at home right now that are just shaking your head at the screen at my shenanigans here. All right, come on now, come on, come on. Oh, I think I found the Konami code. All right, so, well, maybe. We've at least got part of it out. And I'm trying to feel if maybe I got to pull a connector loose or something to get the rest of it. I don't really think I should have to, but stranger things have happened. I can at least get the feed connector loose for the fuel gauge, I think, which, if I can get you guys in here real good, you'll notice is right here. There's a few connectors that feed various things, but this is the one we care about here. We're going to make sure this guy is nice and clean. So pop him loose. I don't know if I can do this one-handed. Yeah, definitely can't. All right, I'm gonna set you guys down. I'm gonna try to put you over where you can see though. Let's see here. Where can I prop you guys up? Okay, so there really isn't a good spot to prop you guys up, but I'm gonna pull you in here as close as I can. So these connectors, they're just a squeeze. These are your squeezy ears here. And so if you can get in here with your fingers and try to work it loose, carefully, I may need both hands to get it carefully out. Oh, no, never mind. All right, until I. You can then check and see if any of these are dirty. And those actually look pretty daggum good. I don't see too much wrong with that, except for maybe this guy. But that's not bad. And little tracies in here, these sometimes get gummed up too, and you can kind of see a couple of them might be. I'm not 100% convinced that they're buggered, but we'll put a little contact cleaner on them and clean them off. Be very, very gentle while you're doing this stuff, because while you're in here, this is just Mylar with some copper in it, and I'm gonna tell you right now, this stuff will tear on you like nobody's business. So be very, very careful while you're doing this, because this cluster these days, trying to get this off eBay, that's expensive. Got me a little CRC contact cleaner on this rag, and I'm just gonna gently wipe across them. Extremely gently wipe across them. Do not go ham. And for you guys that love brake clean, don't use brake clean on this. It'll make this Mylar even more brittle than it already is, being 30 years old. So we're gonna wipe these guys down too. Make sure that, see, all of them are nice and shiny like those guys. Flip it over. Oh yeah, those look pretty good. All right, so the orientation of this connector, the wire should kind of hold it where it goes, but you can always look for which ones are shiny and which ones aren't, for which ones are making contact and which ones weren't. But anyway, we're gonna slide this back in. Yeah, just like that. Well, almost. Yep, there we go. All right, so now that that's done, let's have a look-see and see if maybe that magically fixed things, question mark asterisk, key on. Yeah, nope, directly for infinite, and my hazards are on. Okay, well, we sort of suspected that wouldn't fix it. Okay, so now we get to start looking for other possibilities and connections. So the way this guy works is that back there at the fuel sender, we talked about earlier, back here at this guy, that on the yellow and white striped wire feeds the gauge up here. It's all based on resistance. This is a balanced resistance gauge here. So at 16 ohms, more or less, it's empty, and at 145 to 165, we're full. So, let's see if maybe I can isolate which wire it actually is that we need to look at. I think this calls for a schematic. Now, some of you are probably going, schematics are cheating. Absolutely not. As a certified idiot, I love my schematics. All right, so here we go. Whoa, told you it was windy. All right, here's our schematic. If some of you 7.3 guys need this, hit pause, look this over. This might help you out. So our fuel sender wire, as you can see, comes almost directly off of our switcher, which is what this square here is. And future John should have explained these diodes to you. And then the yellow and white wire, see, YW, comes off that, goes through one connector, and then the connector we just cleaned into the gauge, okay? So it's supposed to be yellow and white all the way to the gauge. Now what may have happened here is we may have got bamboozled, and the connector we just looked at is not actually yellow and white, which has been known to happen. So let's see if we can find it here. We've got some green and white, all kinds of good stuff, except for I don't see yellow and white. And you guys, probably will comment down somewhere telling me I'm an idiot, but I don't see it. Oh, yeah, I do. It's on the far side. So it's on the connector on that end. So we got to flip this guy around. I'm going to do that off camera so I don't bugger this up and end up having to replace it. And we'll get back in a second. Okay, I don't know how well you guys can see because I had to put a work light in here to see what I'm seeing. But you see that yellow and white wire right there? I think that's our huckleberry. So one way to test for this is we know that the senders work off a resistance quotient. So if I pull that apart and put my meter on it and look for resistance on that line, and if it's in the same range, we know we found it. And unfortunately, with these old trucks, as you can kind of tell, the wires tend to fade over time. Heck, on camera, most of those look almost the same color. Trust me, that one's yellow and white. I promise, that one right there. But I'm gonna get this connector out and we'll see what's what. But what I think is we're gonna discover is that that guy is correct in our resistance. Go ahead and comment down below if you think I'm full of it, or if I need to change my diagnostic approach. There's probably some Ford tech in the comments that's going to tell me I'm an absolute moron. But hey, that's why we're here. We're all here to learn. Got our meter hung up here. She's in resistance mode. I went ahead and found a ground point over here in this connector right here that we can go ahead and stick that lead into so we don't have to move it around. And if you guys are ever having to do this on your own, or if you're at home trying to follow my idiocy, look at this connector and you're going to notice that these wires are running into numbered pins. And if you're ever looking at the schematics within the actual manual, you're going to notice that these pin numbers become very important. So this is pin 5, which is the pin that our sense comes in on. And if you, I don't know how well you can see this, but if you notice on the schematic here, pin 5 is annotated right there as the input on the connector. So for those of you who thought I got the wiring idea wrong and couldn't see colors, well, I can read numbers, so I got that going for me. All right, so anyways, let's see if we can't read something off this. And this should be sensing one of the tanks. If it's not, if it's completely and totally buggered, then we got other problems. All right, so I need, let's see, that pin 5. Pin 5 corresponds to this guy. Okay. So we got pin 5. We had pin 5. I lost pin 5. Somebody help me. I need an adult. I'm still crossed. There. Pin 5. Pin 5 is reading out, what is that? You guys help me out. 130 something volts, or not volts, ohms. Come on, John. That's mega ohms though. Come on now. Should be significantly more accurate than that. Get in there. All right, there we go. I got it kind of propped up. Oh, open circuit. Well, all right then. What does that tell us? That tells us our, well, that tells us that our plunger is in an unknown state back at the other end. Ruh-roh. Okay, so wiring troubleshooting 101 for you guys at home. And this is from an old helicopter mechanic. So if you take this pin and we tie it to ground up here, which I'll do with that pin over there I found, and we test for ground on the other end of this wire in the circuit bundle back at the switcher, we should be able to see potential there. And if we see potential there, or at least a closed circuit, then this wire is actually good and there's something else going on. So that's the next thing I'm going to check, see if maybe this wire's got a break in it somewhere. I mean, heck, I don't know. I haven't owned this truck. I mean, look at this. This thing's been used and abused. Look at the goo back here. All right. Well, enough chit-chatting about it. Let's get at it. Here's what we got set up for our test to ground up here. First off, we have a pop rivet that should be just conductive enough, jammed into the ground pin here with an alligator lead on it. This alligator lead goes over to our pin that we care about on our yellow and white wire. Now, what this effectively did is tie one end of this to ground. So now if I go to the other end and test the ground, if I get good continuity, hey, wire's good, problem somewhere else. Here we go. It decided to get real dark real quick under here, and it's also decided to be windy. So hopefully the audio's pretty okay for you guys. I got the wind filter on, but yeah, well, there's only so much I can do with that. But what we're gonna do is we're gonna reach up here and we're gonna pull this connector as best we can. Might need to get a screwdriver. I don't know yet. Yep, definitely need one. But if you remember yesterday, the day before, whatever day it was, everything's running together, we talked about greasing stuff up and being nice to the next guy. Well, this is a prime example of that. You got to be nice to the next guy, because you are the next guy. If I'd have left this all crusty, here I am doing this test again, probably breaking connectors and causing myself all kinds of hell. All right, here we go. So now we found our pin with our yellow and white wire, which is pin, well, second from the left as I'm looking at it, so this guy, and you can see the, I believe, the yellow and white wire right there. So we're going to go ahead and plug into that. Here we go. And then we're going to take our other lead, and we're going to find us a ground point that might be halfway decent on this rusty old truck, and we're going to see if we can't test to ground. So let's see if I can find something. Yeah, there we go. Okay, let me see if I can move the meter where you guys can see it, hopefully without breaking everything apart. So I'm jamming this thing as hard as I can through the rust. And there we go, focus. All right, so we've got some kilo ohms going on. We need to find a better ground point. There we go, that's more like it. So we got some resistance on a line, but nothing that we didn't already expect. In point of fact, I might actually have the wrong wire. I was talking about being colorblind earlier, so, you know, could be that I'm colorblind right now. Ah! You guys fell down and went boom. All right, so going back to the well here on the wiring. Yeah, yellow and white stripe. Interesting. Well, let's check the other one. What do we get on the other one? Yes, Mr. Meter, I know you've been on for a minute. It likes to yell at you. You know, it's a feature. All right, here we go. Jam this guy in here. What do we got? Anything? Something? Got a lot of nothing because of this rusty old frame. Let's see if I can scrape clean some areas here. No. Okay, let me find a cleaner ground point before I proceed too much further. I think there's actually a ground in this harness, if my memory serves, and I want to say it's that blue wire right there. So that would be third from where I'm at. So let's try that. No, of course not. Can't be that easy. Let's try the next one. No. One after that. No. Are any of you ground? Hello? Major Tom to ground control. Oh, it might be the blue wire actually. What is this? Blue with yellow stripe. Let me go check the schematic. Oh. Schematic says BK black. Interesting. Well, that doesn't match up with, oh no, that's at the fuel tank selector switch. Correction, don't listen to me. There is not a ground there. Okay, well that makes a lot more sense. Let's find us a better ground point. Let me go get my alligator leads here. And just tried to brain myself on the frame of the truck. Turns out the frame of the truck's harder than my head. Who knew? Let's try one of these bolts here. Maybe that'll be a little bit better. I really don't think this wire is bad. That's why I'm going to this kind of length. So, because it reads intermittently. Of course, it might have a break. Okay, so we got about 170-ish ohms on that line, and that line should be the forward tank sender, so that makes a lot of sense. So let's try our gauge wire again. Here we go. Let me get this back in focus for you guys. Back on my good ground. What we got? We got confusion. Nice. Well, okay, so we got 6 ohms-ish. And let me wiggle this around to make sure that our reading stays stable. It does. Okay, so we got about 6 ohms on that line. That sort of kind of makes sense with the length of the run. So I'm going to go ahead and call the wiring itself good. So the sender on the on the rear tank is good. Let's try the forward tank. And I believe the forward tank is, let me refer back to the schematic again. Oh, always download the schematic, especially when you're working on something crusty. All right, so the yellow wire was the rear tank. The front tank is dark blue and yellow, which is the one I thought was ground earlier. So there we go. See, my confusion pays off in the end. It hurt itself in confusion. Anybody remember that from the 90s? Probably just scared off the one kid watching this video. All right, here we go. Let's see. Got him in there. I'll get my good ground again. And survey says, well, give me something, guy. Nothing. Really? Maybe I just don't have him in there good. Story of my life. Gotta get deeper. All right, try it again. No, nothing. Uh-oh. Well, that's not half confusing at all, unless I'm in the wrong wire. It's a dark blue with yellow stripe, and all these are starting to look similar. So let me rephrase here. Yeah, dark blue, yellow stripe. That's the one I was in. My mind is boggling. Get in there. All right, here we go again. No, nothing. Okay, well, in that case, I'm going to move you guys back that way a little bit, and we'll pop the connector off the sender and see what we get. 1 second. Okay, so I actually had a better idea. I'm gonna leave you guys up here, and this will work good. And I'm gonna turn the key on like that, and hopefully not lose the camera. Stay put, little guy. I'm depending on you now. And we're gonna ground the far end of the gauge and see if she moves. Because as this thing gets less resistance to ground, it should go to empty. Allegedly. Oh yeah. Okay, so the gauge and the wiring to the gauge are good. We just have issues getting the signal here. Nice. All right, so I'm going to unground that, and that should go back. Indicator what the fault is too. So is she moving? Oh, she is. Okay. That means high resistance in the actual line. Uh-oh. Yeah. So as I continue in blissful ignorance, unaware of the fact that my microphone is about as alive as my fuel gauge, what I'm trying to explain to you here is that every time I actuate the switch, I'm actually not hearing any action happen back at the actual fuel switcher. There's no ka-chunk-ka-chunks, no spin-em-a-things, no nothing. So what I'm doing is I'm trying to wiggle the connector and see if maybe that's the case. And then I'm pointing out that we just got through testing the wires, and unfortunately for us, they're all good. So the next course of action is going to be, once again, let's consult the schematic, because if all else fails, read the manual. Let's ponder this some more with our calibrated wood. Get out of the way. Great paperweight, not very transparent. So if we chose to try to manually actuate this, it would seem to me that we could close the circuit on one of these and get this thing to move. So if we were to close the circuit on those two pins there, pin 3 and 4, we should be able to make this thing rock over. Do I dare do that? And if so, that just means I got a bad selector switch into a gummed up one, which is a lot better than, you know, the alternative. Yeah, I think I'm gonna try that. Okay, change plans. So for those of you who don't know how to read a pinout and need to figure out which pin is what, especially when you've got these specialty Ford connectors that, you know, I don't know who uses these things. Normally the pinout is read left to right, okay? So in this case, what I'm doing is I'm finding the color of wire, so brown and white, black, red, and figuring out which pin is what. So pin 1 should be red, so over here I'm looking at the wiring bundle, and there's pin 1, pin 1's red. And the next one should be ground, and we already know this is a ground pin from earlier, so there's my black wire. And then sure enough, pin 3, brown and white, there she is, brown and white. All right, so to get this thing to flip over, looks like we need to connect pin 4, which will wind back around to here, by the by. We need to connect pin 4 to ground, so we're going to jump that guy to the black wire. And then we're going to need to apply 12 volt power from pin 5, which should be this red wire here in the middle, to this terminal, and then we should have something actuate. Now, to go back the other way, naturally we'd be applying 12 volt power to pin 6, which is the pin directly below it, kind of conveniently. So, anyways, that's what I am fixing to do. I'm going to set this guy up with some alligator leads and a pin that we can test with, and we're going to see if we can make this thing flip back and forth. If we can, and it's getting stuck in between, I think my switch might be bad. Here we go. Now I know there's at least one person down in the comments that's going to look at this and call it out for what it is, and that is a fire hazard. but it should work for our testing purposes. I have this pin insulated with the rubber gasket there, and everything else is kind of hanging tested in there, and you know, it shouldn't be touching. So we're going to try to ideally swap this guy between tanks. All right, power on. I'm going to touch the end of our power lead to this. Yep. And I heard the actuator actuate. Yep, and it's gone as far as it can go because our diode circuit of protection has kicked in, so it is as far as it can go. Now for the big reveal. With the power on, same symptoms. Okay, so now that we've established we're on what I think is the front tank, I have been wrong before. I'll turn power back off before I fry something. And we're going to retool this guy to apply, let's see, we're applying ground now for our purposes to pin 1. So we need to change this setup around. So I'm going to move this test pin over to pin 1 here. And then I'm going to repin our power test here to pin 6, which is the one directly below it right there. And we're going to try this again, see if we can swap back the other direction. Here we go. I think I've got everything hung up. Power back on. We're going to give her the old tap and see what happens. Ooh, nothing. Uh-oh. Got a bad connection somewhere? Proceeds to wiggle all the things. Okay, let's check our pins. So, should be in pin 1 headed to ground, which is what is going on there. I should also be in pin 6. There's pin 6 here, headed to power, which I think is what I have going on here. Let's give her another go before I get the meter out. Nothing. Do we have powers? We don't have power. I might have popped the fuse when I ill-advisedly just did that test. Well, let's find out. Ain't one thing, it's another. All right, I'll be back. Yeah, see, let this be a lesson, you guys. I don't know if you can see it too well, but yeah, fuses are important. Leave these guys the right value, because what I just did, it shouldn't be done, but you know, it could happen while you're driving, wires get crossed or whatever. Make sure these things are good, because you know, you don't want to overvolt something or overcurrent something in this case. Yeah, I'm dumb. Don't do what I do at home. I'm going to put a new fuse. We're going to try the reverse. Probably blow that fuse too, but at least we'll have proof of concept that it goes back and forth. Here we go. Okay, I put a new 20 amp fuse. We're going to test my jankiness. I'm only going to try to touch it momentarily this time to ideally not blow it up. Here we go. Yep, we have power. We definitely have power. And that would be the fuse popping there. Okay, so I didn't hear the thing actuate back there at all. But since I'm not made of fuses, I'm going to change this guy back out. And obviously I don't want to melt wires. I'm going to take the switch off the panel there and apply it here directly. And we're going to do some additional testing. However, if you guys choose to do this kind of crap, be sure you got a fuse, because this can burn your whole rig down. Don't do what I do. Don't be dumb. I mean, unless you're me. Okay, got our switch hang tested here. Hang tested. Let's see if we can get anything out of this. Alright, rear, which should be reading because its sender's good, and it's not. Front, nothing. Rear, nothing. And the wind is really picking up tonight. I may have to continue this tomorrow. But it looks to me like what's going on here is that our actuator isn't actuating and it's stuck in the middle, which is really weird and bad, assuming the switch is good. Fun times. And since I'm not made out of fuses, I'm not going to continue trying to do a simulation of this here switch, even though that should have worked fine. So it begs the question of why the heck did that try to pop the fuse? Because in our production diode setup here, it should only go so far before it gets to the other pad. See the two little switchy points here? and the current can't flow anymore. So I think it's stuck in the middle here, or it's some kind of failure mode on the switcher itself, which really sucks because we just put that one in. But yeah, the wind is really getting with it right now, and I think we're going to have to continue this tomorrow, guys. Okay, it's the next day. I don't know which one of y'all turned up the wind, but you know, if you could turn that back down, that would help. But I found out I made an uh-oh. So if we look here at our schematic, well, I had the pins crossed last night, and that's why the fuse popped. Let that be a lesson to everyone. Don't work tired. It never works out well. All right, so I'm gonna get back in here. I'm gonna set my tools back up, and we're gonna get back at it. All right, I'm gonna try to show you guys real quick the little diagram and stuff I did. Again, don't, you know, this is me. If you're not comfortable, don't do this. So I made myself a position chart while I was on lunch at work today so that I could put the test leads in the correct positions if we go back that route. I think I'm gonna do a voltage check first, but this will help us out. So if you look here, we've got our various pins. So pin 6 in position 1 gets tied to pin 5, okay? And then pin 4 in position 1 is tied to pin 2. If we change positions, then we get pin 3 tied to pin 5, and then we get pin 1 tied to pin 2. And what I actually think happened last night is I got these crossed. I went back and looked at the footage, and I could kind of tell that I did, but I'm, you know, not incredibly certain. Still, if you guys are doing electrical troubleshooting and you got a multi-position switch with 2 circuits running through it, make a position chart for the pins, because it really, really helps. Okay, so like I was saying, we're gonna do a voltage check, and we're gonna do a voltage check really to test this guy, this switch right here. I am suspect. If this doesn't work, I'm gonna go back to alligator clips and everybody can wince at the camera as I, you know, bumble around. What we're gonna do is we're gonna leave this in the front position. I've got the meter hooked up below us, and we're gonna turn on power and see what we get. Now, most likely what's gonna happen here is that we're gonna get our 12 volts where we should, but stranger things have occurred. All right, voltage on. Well, hopefully you guys, shoot. My filming sucks today, guys. Real bad. All right, so hopefully you guys can see that. We got about 11 volts there in that position. All right, I'm gonna swap it back the other way. And hopefully by doing that, we can check for voltage. So we should have negative volts now. And the current lead position is 11.52. So allegedly our switcher circuit is working at the switch. Why you no move? I'm gonna set you down against the wood here. I'm going to retool this and plug this guy back in hot, wiggle it around. Don't do this at home, he says as he explains what he's doing. All right, got him plugged in. Let me see if this made any difference whatsoever, and if we can get this thing to switch. I don't hear it doing much. Well, either one of 2 things happened. Either I fried the switcher up here, possible, or we're not making contact and not able to actually get a switch happen. Okay. So let's see, what can we do here? We could hang test the old motor and hook it up and see if it'll actually spin. That's an idea. But I kind of don't want to do that because there's no telling what condition it's in, A. But B, more importantly, I've already put it on the power supply, so, you know, might be a little iffy. Let me see if I can get an assistant to flip the switch for me up at the top. Be right back. Okay, go ahead and hit the switch. Do it again. We're getting nothing. All right, let me wiggle this. Do it again. Again. Nothing happened. Interesting. Okay, so I don't know who turned up the wind, and hopefully you guys can hear me. So what we've got set up here is we've got a pin on one side of the power and a pin on the other side of the power. Remember, the switches, based on the position of the switch, go forward and backward, right? So, got our old motor set up here with our 2 terminals. I've got 1 terminal already wired up. Let's see if this guy spins. It does indeed. Quite handily. I don't know if you guys can hear that. I'm gonna try to get closer to the mic. But yeah, she's spinning my thing in. So, what's going on here is that our motor inside our new switcher is not. So, what does that tell us? It tells us the switcher is probably bad. I'm going to apply power to it directly on the proper pins and see what we get, but this kind of stuff happens. Welcome to troubleshooting. Okay guys, hopefully you can still hear me. So we've set up another fire hazard here. We're going to apply power directly to the motor pins on the device from our connector while we feed the actual reading from that back into our meter over here. I gotta do a little bit more balancing to see if I can get this squared up where it's not touching. I believe I already mentioned this. I'm an idiot. Don't do what I do. All right, so this should allegedly give us a reading on both the voltage drop from the actual device up here and let us see if the motor is going to actuate. So, can I get a key on? Key's on. We got 12 volts. Motor no move. Uh-oh. That's not good for this component. All right, key off. All right, so now I'm going to reverse the circuit polarity, which should make the motor go back the other direction, allegedly. All right, key on. Still got good voltage, no motor. Okay, key off. I'll check my connections at the motor, but I'm reasonably sure that this guy is done. And I'm gonna have to order another one and take another bath in diesel fuel. Okay, key on. Oh, I felt the twitch. I felt the twitch. Maybe I wasn't making good contact. All right, key off. All right, let's see if we can send it back the other direction. Carefully. And before you guys ask, no, this is not the correct way to do this, but this is the way I am doing this. Okay, key on. Flip the switch. Do it again. Okay. Key off. So I felt the slightest twitch, but nothing when my lovely assistant up there flipped the switch for me. Still getting good voltage though, so got that going for me. All right, key on. Flip the switch. Flip it back. Okay. Key off. All right, I'm gonna check my connections up here. Make sure that I'm making good contact with the drive pins. In most circumstances, when I do this, I've got a lot more space to work with and a lot more surface area to contact with my little leads. All right, key on? Nothing. Okay, key off? All right, back the other direction. Key on? We've got only 9 volts now. Let's flip the switch. -9, yep, so the switch is flipping between the two, but why is the voltage fluctuating? I think I had a alligator lead touching. Flip the switch. Yep, nothing. Looks like our switcher's dead, boys. Okay, we're back. Things have escalated. We're gonna hang test this guy, and we're gonna apply power and see if we can get this guy to cycle. If this guy cycles, we're gonna do the old switcheroo. If it doesn't, my diagnosis is way off. Here we go. All right, key on. That's supposed to stop at some point. Go back the other way with the switch. All right, forward. Back. Okay, one successful hang test later, we have our answer. So remember I made this position chart earlier, which lays out which position all the contacts should be in, or which ones should be conducting together. Yeah, I think we got a problem with this guy. So in position 1, pin 6 right here should be connected with pin 5, which is this guy over here internally to the switch. So when this guy switches over, this trace right here is energized. So I should be able to test between these two and get continuity inside the switch. And then 4 to 2, 4 to pin 2 down here for ground should be connected, just like it's illustrated. So when I put it in either position, neither one of these things work properly at all. Both of these positions are off, and I can actually prove that. So if you look inside here, start with this pin here and count up. So this is 1, 2, 3, 4, 5, 6. Okay? So if I test from 6 to 5, so that'd be these two terminals, I don't have continuity. And I should, allegedly, according to this chart, in either position. So what we'll do is we'll take our alligator clips, and I'm going to try to one-hand this, reach in here with them. Probably block your view while I'm at it. There's one. And you know what? Hang out here for a second. Get in there. All right. So alligator leads are now on those two pins. So with our multimeter set for continuity, flip it one way, nada, flip it the other way, continuity. Okay, so I'm wrong. That position does work. All right, so now 4 to 2 should be connected. I think that was the one that didn't work. So in this position with 6 to 5 connected, if we look here, 4 and 2, focus, 4 and 2 should be connected, allegedly. All right, so let's hook up 4 and 2. There we go. All right, so 2 and 4 are connected. You guys can sort of kind of see that. It's a little blurry. Try to get this thing to focus a little better. There you go. Yeah, you can see, right? All right, so 4 and 2 are connected. And we have open line. Now if we flop positions on the switch, still open line. Flop back the other way, open line. Interestingly though, if we test the other position, I'll bet you one of these is actually connected. And I think I know which one it is. So if we look at 3 and 5, we get nothing in this position. But if we look at 1 and 2 in this position, Still get nothing. Okay. Well, that's cool. Which one used ground today? Ooh, okay, so that's weird. So actually what's going on here is that pin 2 and 3 in the rear position that we just had it in, where 6 and 5 are actually connected, are going to ground. So we got pin 3 connected to ground. Methinks that'll blow up a motor. Probably what happened to our old one and the new one that I just, fried. The new one's still okay in there. It's doing the thing, but I'm not willing to run it through this switch too much. I've got a new one of these. It should be here in a few hours. We can try that. All right, so now if we go to position 2, since this is the 6 and 5 position, so position 2 is allegedly going to be front, so we flip to front. So we're going to lose connectivity there, but so pins 3 and 5 should be connected. All right, 3 and 5 are connected, as you can see. Oops, nope, that's 1 and 5. Correction, don't listen to me. There, now 3 and 5 are connected. Just make sure you're paying attention. All right, so 3 and 5 are connected, open line. That's not good. So let's try 1 to 2 real quick. And that does work. So our ground circuit on position 2, which is allegedly front, is working. Now we got to figure out where we're getting actual power. So pin 3 should be the power pin, and we got to figure out which one of these it's still connected to. Or it might be pin 5 that it's pulling off of. Either way, it's not very happy. Okay. So in this configuration, in the front configuration, pins 4 and 5 are actually connected. So that means pin 4 right here is connected here. Something wrong. So with 3 and 5 connected, so these 3 should be connected to power, but 4 is also connected to power. Say what? This is a definite problem. I think this switch has had its last hurrah. But hey, it's a genuine faux moco, probably selling on eBay for 20 bucks. Yes, I know. I'm not trying to run your battery down. Relax, guy. All right. So now that we've gone through that little exercise, let me see if I can get the new switch out of the mailbox and slam that guy in and see what it does. I'm going to test it on the bench here first as well, following our schematic, to make sure that its logic matches up with what I think this thing should be doing. But probably what occurred is that this switch failed. It's been in front position. Front position is shorted to the wrong pin and eventually burned up our little DC motor. Well, not eventually. Yesterday with the new one, it burned up fairly quickly, but for the old one, it took a minute. So we're going to go ahead and swap this guy out, and I might even tear this guy down because, science. Power on, switch installed. Yep, still trying to blow up the motor in the front position. So I'm not entirely sure what's going on here. This thing is acting differently than what I would think it would on the schematic, but this is shade tree mechanic time. So I think we got a wire fault somewhere. It's time to start shooting wires and see if we can't figure this out. My favorite. All right, guys, we're learning together. So these replacement valve assemblies come shipped with dielectric grease in them, which isn't necessarily conductive. And as you can see on our PCB that we went over earlier, there is a stop switch set up with these diodes between these two pads here on the PCB. So what's happening is that mechanical motion back and forth is finding the pad on the PCB where current stops and stopping the switch. So, symptom I had here is this guy was just spinning the thing in and forward, and reverse it was finding the stop. So I kept having to rock this back and forth until it finally made contact with both. That's probably why that one failed. So, you know, learn from me. These things come shipped with a lot of shmoo in them. You need to rock them back and forth so they start making contact. Now, I've got to take this, replace that, and you know, do all the things all over again, and we should have a switcher. Now, I did put the new switch in, and the schematic actually is for a 97, which I didn't think they changed too much between the years, but they probably did. And all of the wires trace out with the positions on the switch. So, allegedly, as I tell a ghost story here with the freaking flashlight, allegedly, this will work. But I'm gonna swap this thing carefully this time. I don't really feel like taking another bath in diesel. Here we go. All right, here's a tip for you guys. If you're working on these, get yourself a chunk of hose, stick a bolt in it, clamp it down, because you're gonna need a block off, depending on what position this valve is in. These lines, when you disconnect them, are gonna leak. Have a catch pan. But you're gonna have to swap them quick to keep them from leaking, and one of them is gonna be in a position. In this case, it was, so it starts leaking out the send, because, you know, gravity's a thing. So block this guy off, save your day. Okay, so I did get it swapped out, as you can see. So I'm gonna clip these tails. I'm gonna do that before I get done, but look at him right there. He's all nice and happy and tucked in. So learn from me. With these guys, you got to run them in when you put them in. So that means toggle your switch back and forth a few times until you hear this thing find all of its positions. It's not a computer, it's just a set of diodes, but it has to make contact. I'm sure Future John already went over that. Anyways, so the next step is reassemble that, enjoy our nice new switch with, you know, legible letters, and yeah, profit. Of course, there is still one problem that I'm ignoring judiciously. The sender in that guy is not terribly happy. I'm kind of hoping running it down some rough roads makes it, you know, de-gookify itself and start working, because I am not really relishing dropping that tank, because getting to that is a pain, and the work bed is on here. It's not coming off. Anyway, see you in the cab. All right, so with all this working now, and with a quick wardrobe change to another junk shirt that I'll never wear anyway, you know, diesel, I'm gonna go ahead and run through all these clippies, change them out real quick. All my lights have died, so I'm in the dark, so I'm gonna do that. I'll bring you back in tomorrow where you can see what was happening, and we'll talk through a few things, and that should do it for this little saga, at least I hope, because I am really, really tired of taking baths in diesel. It don't smell good, guys. I don't care if you're a diesel mech. Hey, if you like that smell and that's your cologne, more power to you. It ain't mine. See you in a bit. All right, guys, we're back on this again. The Dorman component down here has decided to strip itself out. So if I apply power and turn on the key, it just spins. Doesn't go either direction. And we shot the wires and checked the polarity and everything's fine. So we're going with the more expensive part that the Ford houses use. This is the standard FV12. And I'm gonna slam this thing in, hang test it, and see if we can get her going. Sometimes buy the expensive component. Sometimes you get what you pay for. Here we go. I want to point out real fast, it's also raining now. Well, this is from me soaking up the diesel. This is gonna go away. But yeah, it's now raining. So yeah, it's gonna be a quick swap. I'm gonna try to film some of it, but you guys might not get all of it. It is what it is. So just in case you guys think I'm full of it, you can probably hear it. This thing, I'm gonna try to get the mic close, is just spinning in the housing. So if you remember our teardown, what actually happened here is this DC motor inside has wallered out the plastic bit. And so that's what we got. We're not going between tanks, we're stuck on rear. So I'm gonna slam the new one in, and I will come back to you and we'll see if it works. It works. It actually switches, there's clicky clackies, and yeah, I guess buy the FV12. I've gone through 2 of these Dormans and I'm kind of tired of it. So anyways, there you go. All right, as promised, we have everything buttoned back up. Everything's back together. Everybody's happy. We even have, look at this, look at this, look at this. We even have a nice new switcher. Look at that guy. You can actually read it. First time in probably 20 years, because, you know, 30 years ago, this thing just went away. So everything works now. The fuel cylinders work. I mean, you can notice the fuel gauge last position. It's not, 7 million% past full. And the repair seems to be holding. Now, my final tip for you guys is when you get these little cinders, run them in. I know I mentioned it earlier, but please run them in, because that grease apparently messes them up, and they'll try to just keep going and going and going until they make contact on another diode pad. Don't be like me. But hey, I hope you enjoyed it, and remember, kindness is free and tech is awesome. Okay, so one thing I did notice while I was working on this thing is that it was absolutely filthy. The previous owner did not keep this truck well. He got oil all over the place. There was a couple of rolls of tape. I mean, I even found a makeup brush in the bottom of the floor pan at one point. And so after I got done, I took to cleaning this thing. We cleaned the carpet, we cleaned the seats. I even hung up the carpet outside to dry for a while, which, this took an absolute ice age for it to dry, but it looks a lot better now. It's actually clean, sanitary. I don't feel bad laying on it. I even replaced the headliner with some leftover material I had. I mean, I got fingerprints all over it while I was smoothing it out, but hey, it is what it is. And it looks a lot better than saggy, holy nonsense. The carpet and the seats are clean enough now that I find it sanitary enough for the four-legged friends to get into, and now it's a good truck.